This video will demonstrate how to evaluate the capacity of a controller with a predefined list of devices using Integrated Architecture Builder, or IAB. Launch IAB by double-clicking the desktop icon. When the IAB menu page appears, select New Project under Create. Enter the workspace name Machine 1 for this example, then select one of the many available wizards. In our case, select the EIP Capacity tool, since we want an overview of the capabilities and limitations of an architecture with one controller and a few other automation devices. Click OK and wait for the tool to open. With the wizard open, we can now create our architecture with a few simple clicks. First, let's select a controller that supports SIP motion. Since we have a small system, select the smallest CompactLogix 5380 controller with SIP motion, the 5069 L306 ERM. Next, we will add some remote I/O. Click the gear icon to open the I/O selection dialog. Let's select our I/O from the same family of products as the controller, 5069 Compact I/O. When selecting I/O, the type, quantity, and the RPI, or requested packet interval, expressed in milliseconds, must be entered. Logix controllers transmit data at the RPI configured for the device. Select 2 digital modules and 1 analog module. Leave the RPI at the default values. Click OK to move to the next I/O device. Select the PowerFlex 525 drive with a quantity of 2 per the system specifications. Once again, leave the RPI value at the default rate. Notice that we may be asked if we'd like to establish an internet connection. This allows any updates to be retrieved before continuing on. This is not necessary for the tool to function, as it will use the information downloaded the last time it was updated. Let's add one additional device, a PowerFlex 527 drive with motion capabilities. Notice there is no RPI value to enter because the data rate will be handled differently. As soon as we click OK, a warning appears letting us know that this device has built-in safety features. To enable those features, a safety controller must be used. This is important information. Since we want to use those safety features, we must select a different controller. Had this message not appeared, we would have used the wrong controller in our system. So we go back to select a new controller, a CompactLogix 5380 with safety, the 5069 L306 ERMS. Once again, this is the smallest safety controller that supports SIP motion. The warning disappears, and we can now compute the estimated use of CPU and network resources. Click the Compute button at the left side of the window. The tool shows the controller using only 4 nodes. The number of nodes is the number of devices that the controller needs to communicate within this system. This controller supports a maximum of 16 nodes, so there are 12 nodes remaining, and we are well within the maximum node limit for this controller. Everything is showing green, which means that this system is viable and should function well as configured. Let's see what happens if we use a faster RPI value with the I/O modules. Open the configuration dialog window, then lower the RPI values. The Logix data will be transferred at a much faster rate with these new settings. Select OK to confirm the changes, then click Compute. Everything is still green, and the media utilization is at a very low level. This is still a viable network configuration. Wait, we just noticed the use of 1 non-position axis, but this was not in the specifications, so let's change it. Open the PowerFlex 527 configuration again, and change to Position Axis Type, then click OK. Click Compute once again and see the available number of drives changing from non-position to position axes. In this controller, the maximum number of axes is 2. This means it is not possible to control 3 axes such as X, Y, and Z with this controller. Remember that we selected the smallest safety controller in the CompactLogix 5380 family. What will happen if we speed up the communications rate with the 2 standard drives to provide tighter control? Lower the RPI values to 5 milliseconds, then click Compute again. Everything is still green, and the media utilization has increased, but only slightly. Now let's see what happens if we change the network infrastructure type to linear. We'll need to recalculate the capacity by clicking the Compute button. After reviewing the results, change to a ring topology. Notice, the numbers are always the same because neither the controller nor the connected devices have been modified. The tool provides another useful option, which is to take a snapshot of the current architecture. Click on the camera icon on the right side of the page, then save the image. Select a name that is both descriptive and consistent with the application. This image can now be shared electronically, such as via email or simply stored for future reference. Before moving on, though, let's take a snapshot of the linear topology network as well. Topology is required. We can add an Ethernet switch to our system. If a star topology is required, we can add an Ethernet switch to our system. Click the gear icon next to the catalog number field. A list of available switches appears. To keep the cost of the switch as low as possible, select a lightly managed switch from the Stratix 2500 family. This switch meets the needs of our application because advanced options such as NAT or DLR are not required. Click OK to confirm the selection. Click Compute once again, then take another snapshot with the switch in a star topology. These snapshots are very useful, but a report with detailed information about the devices and network performance data would be helpful as well. Select the Export Report button located under the camera icon, then save the system information in Excel. Notice that the report contains configuration details, the number of SIP and TCP connections used, as well as the estimated utilization in packets per second. One last step is to save the configuration in the event we want the option to continue modifying the configuration at a later time. This automatically generates an IAB project, which can be viewed or edited in the future.